The parametric equations of the curve C are x equals t squared and y equals 2t. Show that the normal to C at the point P with parameter P has equation y plus px equals p cubed plus 2p. The normal to C at the point P intersects C again at the point with parameter 3. Show that p cubed minus 7p minus 6 equals 0. Hence, show that P can be one of 2 points. Find the coordinates of each of these 2 points. So I've got the question here. Here's the curve then in parametric form. Normal at P with parameter P has this equation first of all. So x equals t squared, y equals 2t. So this was part A, wasn't it? Part A? Yeah, x equals t squared, y equals 2t. So x equals 2t, x equals t squared, get it right in a minute, and y equals 2t. So dx dt, differentiate with respect to t as a power rule, 2t to the 1, dy dt, t goes to 1, so this is just 2, so dy dx then, the gradient of the tangent is equal to dy dt divided by dx dt, so it's 2 over 2t. The 2's cancel and that's just 1 over t. So therefore gradient of normal at P, first of all the points, P has parameter P, doesn't it? So the coordinates will be P squared, lowercase I think it was, wasn't it? P squared, and then 2p. Normal has gradient. So this is the gradient of the tangent, so the gradient of the normal will be minus t, but the parameter is p, isn't it? So it's minus p. So there's our gradient of the normal. So the equation then of the normal is y minus the y value, 2p, is equal to the gradient, minus p, times x minus the p squared. So let's see what we've got here then. We need y plus px. So let's move this minus px over to be with the y. And that will equal, move the 2p over here to plus 2p. We've got a minus times a minus is a plus, p squared times p is p cubed, which was what we wanted to show. Yeah, which equals, and write it around the other way, p squared plus 2p. Okay. Oh, p cubed. So this was p cubed, wasn't it? Sorry. And that's handy. Handy little check there in the question. So that was that times that is p cubed. And that gives p cubed plus 2p, which is what we wanted. So that's helpful from the question. The normal to C at P intersects C again at the point with parameter 3. So this normal at parameter 3, so at the parameter 3, so 9, 3 squared is 9, and this will be 2 3s is 6. We see that. So this line cuts this point here, 9, 6. So the y value will be 6 plus p times the x value, which is 9. So we can write that as 9p is equal to 2p plus p cubed. So that tells us then that p cubed, move this 9p over to minus 9p, 2 minus 9 is minus 7p, and move the 6 over minus 6 equals 0. So there we go, that's our cubic in p. Hence show that p can be one of 2 roots and find these coordinates. So when does this have a root? Okay, p is minus 1. Gives. So if we put p as minus 1 in here, then we'll get minus 1 cubed, which is minus 1. Minus times minus is a plus. 7 times 1 is 7. Minus 6 equals 0. So p minus this value, so it's p minus minus 1, is a factor. So let's just divide it through then and see what we get. So let's divide p plus 1. Well, p plus, let's just write this down. Let's do it the easy way rather than do long division. So we've got p cubed then, minus 7p minus 6 is equal to ap squared plus bp plus c times p plus 1. So what does that tell us then? Well, if we equate p cubed terms, we see that 1 on this side is equal to, and we're going to get an a on this side. A equals 1. Okay, so what next now? So we equated p cubed. Should we equate the constants next? So constants gives minus 6 on this side is the constant. And here we've got c. So c equals minus 6. And there's the next value. Right. And then what's best to do next? Should we do p or p squared? Let's do p squared. So the p squared terms on both sides, there's none on this side, is equal to, now we've got ap squared times 1, which is an a. And then we've got bp times p, which is plus b. So that tells us that b is equal to minus a. A is 1, so b is minus 1. So we've got, we've got p cubed minus 7p minus 6 is equal to a, which is 1p squared, minus 6p minus, minus 1p, because b is minus 1. And then we've got c, which is minus 6 times p plus 1. So here, what have we got then? We can factorize this, hopefully. 2 3s. So this would be minus 3 plus 2, wouldn't it? P squared plus 2 minus 3 is minus p. Minus times plus is a minus 3, 2 is a 6. So that gives us that p is equal to minus 1. P equals 3, or p equals minus 2. So let's go back to our original problem then. I have 2 points and find these coordinates. So show that this equals 0. Okay, find these coordinates. Okay, so right, hence show that p can be one of 2 points and find these coordinates. Let's have a look at the points then. So p equals minus 1. Let's have a look at the points here. We'll get our coordinates are p squared and 2p, aren't they? So let's put them down. P squared is minus 1 squared is 1, and 2p is 2 lots of minus 1 is minus 2. P is 3. We get p squared is 9, and minus 2p is minus 6. And the other point, so that was the 9 minus 6, which was the point that was given, wasn't it? So the other 2 points. So the other point then, p equals minus 2 then, gives the coordinates minus 2 squared is 4. And what do we get? And then the 2t, 2 of these is minus 4. So the coordinates, so answer is, let's just summarize this, it would be 1 minus 2 is the 1 coordinate, the 9 minus 6 was already given, and 4 minus 4. So I'll put it in here as the answer.